Hello everyone and welcome to another video. Today we're going to find derivatives and integrals of various types of functions. So let's get started with derivatives. So the first rule we're going to talk about is the power rule. So the power rule of a function will actually be if f of x basically equals x to the n, then we got f prime of x. F prime of x is how we write the derivative here. F prime of x will be nx to the power of n minus 1. So basically, you're moving the exponent forward and then subtracting the current exponent by 1. So if f of x equals x cubed, then f prime of x equals 3x squared. Let's try it with a problem. So we need to find the derivative of 7x to the 4th power. How can we find the derivative? So we can use the power rule here. So this can be rewritten as 7 times 4x cubed. And then if you multiply 7 and 4x cubed, you get 28x cubed. So this is how we use the power rule here. You can also use the power rule on polynomial functions too. So if f of x equals x squared minus 6x plus 9, we're going to find the derivative of the function. So we can use the power rule in order to find the derivative, since this is a polynomial function. So the first term will have a derivative of 2x minus 6 plus, now since 9 is the same as 9 times x to the 0, so it's the same as 9 times x to the 0 power. The derivative of a constant will be 0. Derivative has to do with slope. So that's why if you say y equals 9, the change in slope will always be 0. So that's basically how you do the power rule. Something else to know is that you have the constant multiple rule. So if f of x equals alright, c, and then we got x to the n. And then basically what we want to do, f prime of x will be equivalent to c times nx to the power of n minus 1. That's the constant multiple rule here. Now we're going to talk about the product and quotient rule. Now, if you're familiar with the product and quotient rule for limits, then derivatives are completely different. What you gotta know is that for the product rule, so let's say you have two functions. H of x will be the product of two functions here. So h of x is f of x times g of x. if we want to rewrite the f of x as h of x as the derivative, then h prime of x will actually be f of x times the g prime of x plus the f prime of x times the g of x. So this is very different from the limit notation. You can't just multiply the derivatives of each of the functions separately. So let's try an example here. So let's say you got this function here. F of x equals 2x plus 1. And then you got 9x minus 5. We can use the product rule, or we can distribute. We can use the product rule in this case. If we were to find f prime of x, we need to know which function, which piece will be f of x, and which piece will be g of x. So, typically the first one should be f, and the second one should be g. So, the first piece of the product rule is f of x, so that's 2x plus 1, times the g prime of x, which is going to be 9. But it is normal to write the constant in front of the expression. Plus, we got 9x minus 5, which is going to be g of x, and then f prime of x is 2. Then we got 2 times 9x minus 5. And then what we're going to do is distribute the 9 and the 2x plus 1. Then we get 18x plus 9 plus 18x minus 5. And that will be equivalent to 36x plus 4. And this is how we use the product rule. Now, what if we were to use the quotient rule? Quotient rule is a bit more complicated. So, if h of x will be equivalent to f of x divided by g of x, then the h prime will be equivalent to, wait for it, g of x times the f prime of x minus the g prime of x times the f of x divided by g of x squared. Then I'll add brackets here, so the whole g of x is squared here. Now let's try a problem. So let's say we have f of x equals 3x minus 6 divided by 2x plus 7. Now, how can we use the quotient rule to find the derivative of the function? So what we want to do is follow the structure of the formula. So we got g of x, which is going to be 2x plus 7 times f prime of x, which is 3, minus the g prime of x is going to be 2, times f of x, which is 3x minus 6, divided by the g of x squared. So that's going to be 2x plus 7 squared. Now, it is very complicated to simplify. However, you can leave it like this. And now one more rule I'd like to talk about is the chain rule. Now, chain rule helps us finding derivatives of exponential, logarithmic, and trigonometric functions, kind of. Yeah. Trig functions. So let's go ahead and find some trig function derivatives now. So there is no specific pattern for how to find derivatives of trig functions. So if f of x is sine x, so let's just go ahead and find some basic trig derivatives here. So I'll be writing the functions on the left-hand side and the derivatives on the right side. So the derivative of sine will be cosine. The derivative of cosine will be negative sine. And now the next two are going to be tangent and cotangent. So derivative of tangent will be secant squared. And derivative of negative cosine will be, hold on, I mean cotangent, yeah. The cotangent x will actually be negative cosecant squared x. And now you got the final two, that's cosecant x is negative cosecant times cotangent. And then you got secant x as secant x times tan x. So that is basically the derivative here. Secant x's derivative will be secant times tangent. And these are just some basic rules here. These are basic rules here, but let's discuss one more rule before we go work on more derivative expressions. We need to discuss about the chain rule. So we can find the derivative of a composite function here. So a composite function is basically something like the f times g inside here of x. Now keep in mind this is not the f of x times the g of x. In that case where we use the product rule. This is the same as the f of the g of x. And basically, to find the derivative of this, we want to go ahead and find the outer. We want to remember outer and inner. So we got the f prime of the g of x times the g prime of x. And that's the chain rule here. Now since we're running out of time, we're going to do some practice problems in another video. And then we'll move on to exponential, implicit differentiation, inverse function derivatives, and logarithmic derivatives. And thank you so much, and we'll see you in another video. Bye.